Hello, I welcome you all to the session of financial analysis using discounting and non-discounting techniques. In the first session, we discussed the meaning of discounting and non-discounting techniques with a special focus on accounting rate of return, payback period and net present value. Now, in this session, we are going to discuss IRR, BCR, PI, merits and demerits of each, NPV versus IRR, pitfalls, no IRR, multiple IRR, incremental IRR, the choice between NPV and IRR, specific project decisions like equivalent annual value, unequal lives of projects, adjustment for inflation and projects with resource constraint, etc. The other important discounting technique is internal rate of return. Let's understand this technique in more detail. It is a discounted technique for appraising capital budgeting proposals. This technique is also known as yield on investment, marginal efficiency of capital, marginal productivity of capital, rate of return, etc. It is the rate of return that a project usually earns. This is defined as the rate at which the net present value of the investment is zero. The discounted cash inflow is equal to the discounted cash outflow. This method also considers time value of money. It tries to arrive to a rate of interest at which funds invested in the project could be repaid out of the cash inflows. However, computation of IRR is a very tedious task. It is called internal rate because it depends solely on the outlay and proceeds associated with the project and not any rate determined outside the investment. It can be determined by solving the equation. If IRR is greater than WACC, then the project is profitable. If IRR is greater than K, you should accept the project. If IRR is less than K, one should reject the project. IRR is easier to understand. Business executives and non-technical people understand the concept of IRR much more readily than the concept of NPV. It is consistent with the overall objective of wealth maximization. The IRR is compared with the required rate of return. The required rate of return is the minimum rate which the investors expect on their investment. The IRR suffers from some serious limitations. It involves tedious calculations. Moreover, it produces multiple rates which can be confusing. As an investment decision tool, the calculated IRR should not be used to rate mutually exclusive projects, but only to decide whether a single project is worth investing or not. In the evaluation of mutually exclusive proposals, the project with the highest IRR would be selected. In practice, it may not turn out to be the best. Moreover, this technique is based on the assumption of reinvestment of all cash inflows at the internal rate of return. If the internal rate of return from different machines are different, then it is ridiculous to think that the same company can have the ability to reinvest the cash flows at different rates. In fact, sometimes it is not possible for the companies to reinvest all the cash inflows because companies may pay a portion of cash inflows as dividends. With certain cash flow streams, it is mathematically possible to produce negative IRRs or multiple IRRs for the cash stream more than one discount rate that leads to a zero NPV. For other cash flow streams, there is simply no mathematically correct IRR solution. Now let us understand a very important concept of impossible IRR. There is no possible IRR solution when the cash flow includes only positive or only negative net cash flows. There may be real cash outflows in every period, but when the inflows always outweigh outflows, there will be no negative net cash flows. There is no IRR in such cases. Other patterns of negative and positive net cash flows can also have no IRR solution. Now let's see what is multiple IRR. A net cash flow stream will have multiple IRRs when it includes more than one sign change. When the first cash flow is negative and the second cash flow is positive, that is one sign change, and there will be one IRR for the stream. If another later net cash flow event is negative, that makes second sign changes. There will be one IRR for every sign change in the cash flow stream. In such cases, it is probably best to consider the IRR closest to the real cost of capital as the true IRR. So, in the case of positive cash flows followed by negative ones and then by positive ones, the IRR may have multiple values. Now let's understand negative IRR. It is also possible for some net cash flow streams to produce a negative IRR value. This signals simply that the investment or action should be considered a net loss. Further quantitative analysis of negative IRRs is not advised. Negative IRRs should certainly be disregarded when the analyst prepares IRR averages or weighted average IRRs for multiple actions. There is one more important concept of incremental IRR. The incremental internal rate of return is an analysis of the financial return to an investor or entity where there are two competing investment opportunities involving different amounts of investment. The analysis is applied to the difference between the cost of the two investments. Thus, you would subtract the cash flows associated with the less expensive alternative from the cash flows associated with the more expensive alternative to arrive at the cash flows applicable to the difference between the two alternatives, and then conduct an internal rate of return analysis on this difference. Based just on quantitative analysis, you would select the more expensive investment opportunity if it has an incremental internal rate of return higher than the minimum return you consider acceptable. However, there are qualitative issues to consider as well, such as whether there is an incremental increase in risk associated with the more expensive investment. Therefore, realistically, the investor must weigh a variety of factors besides just the incremental internal rate of return before making an investment decision. This rate of return may not even be the deciding factor in making an investment decision. If the investor believes that there is a considerable amount of additional risk associated with the more expensive investment opportunity, he or she can adjust for this risk by increasing the minimum return considered acceptable. For example, the minimum rate of return threshold for a low risk investment might be 5%, while the threshold might be 10% for a high risk investment. Let's understand this with an example. ABC International is considering obtaining a color copier, and it can do so either with a lease or an outright purchase. The lease involves a series of payments over the 3-year useful life of the copier, while the purchase option involves more cash up front and some continuing maintenance, but it also has a resale value at the end of its useful life. The following analysis of the incremental differences in the cash flows between the two alternatives reveals that there is a positive incremental internal rate of return for the purchasing option. Barring any other issues such as available cash to buy the copier, the purchasing option therefore appears to be the better alternative. An internal rate of return is an estimate for the potential yield on an investment. Calculating the incremental internal rate of return is a tool to help an investor decide whether the added risk of increased expenditure is worth the potential reward. Generally, if the incremental internal rate of return is higher than the minimum acceptable rate of return, the more expensive investment is considered the better one. Now let's focus on a very important concept of modified internal rate of return. Modified internal rate of return is that rate of compounding which makes the initial cash outflow in 0 year equal to the terminal value of the cash inflows. If the project MIRR is greater than or equal to K, the project proposal should be accepted, and if MIRR is less than K, then reject the project. In case of mutually exclusive projects, the project with the highest MIRR should be selected. MIRR is different from IRR. MIRR is based on the assumption that intermediate cash inflows are reinvested at cost of capital, whereas IRR assumes that intermediate cash inflows are reinvested at IRR. MIRR does not yield negative rates or multiple rates under any circumstances, but IRR may yield negative rates or multiple rates under certain circumstances. The other technique is Profitability Index. It is the index which measures the present value of returns per rupee invested. It is the ratio of the present value of future cash benefits at the required rate of return to the initial cash outflow of the investment. It may be gross or net, net being simply gross minus 1. The formula to calculate profitability index or benefit cost ratio is PI is equal to PV of cash inflows upon initial cash outlay. PI is equal to NPV of benefits upon NPV of cost. All projects with PI greater than 1 are acceptable. This method gives a solution to the problem posed by NPV being an absolute measure. It is not possible to evaluate the projects requiring different initial investments. Profitability Index satisfies almost all the requirements of a sound investment criteria. Now let's compare NPV method with IRR. Both of these techniques are primarily used in capital budgeting. Through these techniques, companies determine whether a new investment or expansion opportunity is worth making an investment or not. Given an investment opportunity, a firm needs to decide whether undertaking the investment will generate net economic profits or losses for the company. To do this, the firm estimates the future cash flows of the project and discounts them into present value amounts using a discount rate that represents the project's cost of capital and its risk. Then a summation of present values of cash inflows is obtained, and subtracting the initial cash outlay required for the investment provides the net present value of the investment. Let's illustrate this with an example. Suppose Jumbo Media Company wants to buy a small publishing company. Jumbo determines that the future cash flows generated by the publisher when discounted at a 12% annual rate yields a present value of rupees 23,000. If the publishing company's owner is willing to sell for rupees 20,000, then the NPV of the project would be rupees 3,000, that is rupees 23 minus rupees 20. The rupees 3 million NPV represents the intrinsic value that will be added to Jumbo Media if it undertakes this acquisition. So, Jumbo Media's project has a positive NPV, but from a business perspective, the firm should also know what rate of return will be generated by this investment. To do this, the firm would simply recalculate the NPV equation, this time setting the NPV factor to 0 and solve for the now unknown discount rate. The rate that is produced by the solution is the project's internal rate of return. For this example, the project's IRR could, depending on the timing and proportions of cash flow distributions, be equal to 17.15%. Thus, Jumbo Media gives its projected cash flows as a project with a 17.15% return. If there were a project that Jumbo could undertake with a higher IRR, it would probably pursue the higher yielding project instead. Thus, we can see that the usefulness of the IRR measurement lies in its ability to represent any investment opportunity's return and to compare it with other possible investments. Now, what are the similarities in these methods? The techniques give consistent results in terms of acceptance or rejection of investment proposals in certain situations. The situations in which the two methods will give a concurrent, that is agreeing, in conventional and independent projects. Now see what are the differences between these two important techniques. In the case of mutually exclusive proposals, these techniques might give a contradictory result. In the case of size disparity problem, this arises when the initial investment in projects under consideration, that is mutually exclusive projects, is different. The cash outlay of some projects is larger than that of others. In case of time disparity problem, this arises when the cash flow pattern of mutually exclusive projects is different. In case of unequal expected lives, another situation in which the IRR and NPV method would give a conflicting ranking to mutually exclusive projects is when the projects have different expected lives. Now let's compare net present value with profitability index. In most situations, the NPV and profitability index provide the same accept and reject decision because both the methods are closely related to each other. The investment proposal will be acceptable if PI is greater than 1, and this is possible only when NPV is positive. In case of mutually exclusive proposals, these methods may give different rankings. Now let us discuss the choice between the NPV and IRR. The conflict between the NPV and IRR method is mainly recognized. The IRR method implicitly assumes that the cash flows generated from the projects are subject to reinvestment rate assumptions of intermediate cash inflows accruing from the projects. The IRR technique is based on the assumption that the cash flows would be reinvested at the IRR, whereas in NPV method, this reinvestment is done at the cost of capital. So, the assumption under NPV is superior to IRR assumption because NPV would provide uniformity and which can be consistently be applied to all investment proposals. The NPV method is considered to be the best under the capital rationing situations. For these reasons, NPV emerges as the theoretically correct and better technique for evaluating and assessing the investment proposals. One important aspect of capital budgeting is capital rationing or project with resource constraints. It refers to the situation of choosing investment proposals under financial constraints. Every company has a financial budget and this makes the process more complex. The limited capital budgeting funds makes it inevitable to make a right choice. The project selection under capital rationing involves two stages: identification of the acceptable projects and selection of the combination of projects. There are two types of capital rationing proposals: soft rationing and hard rationing. Soft capital rationing or internal rationing is caused due to the internal policies of the company. The company may voluntarily have certain restrictions that limit the amount of funds available for investments in projects. On the other hand, hard capital rationing or external rationing occurs when the company faces problems in raising funds in the external equity markets. This can lead to the shortage of capital to finance the new projects in the company. Capital rationing does not allow the firm to accept all profitable projects which could add to the net present value and adding to the wealth of shareholders. Capital rationing may lead to the acceptance of several small investment projects which might have a bearing on the risk complexion of the business firm. For making a correct selection, the companies should rely on Profitability Index being a relative measure compared to the NPV method, which is an absolute measure. Profitability Index should be used to rank the divisible projects under the capital rationing situation. The other aspect of capital budgeting decisions is unequal lives of project. It is also a very important aspect of capital budgeting. As mentioned previously, NPV and IRR can sometimes lead to conflicting results in the analysis of mutually exclusive projects. One reason for this potential problem is the timing of the cash flows of the mutually exclusive projects. As a result, we need to adjust for the timing issue in order to correct this problem. There are two methods used to make the adjustments: replacement chain method, equivalent annual annuity method. The replacement chain method is a decision model that takes into consideration the different lifespans of alternative proposals, allowing a more accurate comparison of the proposals. In replacement chain analysis, the net present value is determined for each proposal and one or more iterations can be completed to create comparable time frames for the proposals. By comparing the proposals over like periods of time, accept reject information for the various proposals becomes more reliable. The equivalent annual annuity approach calculates the constant annual cash flow generated by a project over its lifespan if it was an annuity. The equivalent annual annuity approach is one of two methods used in capital budgeting to compare mutually exclusive projects with unequal lives. The present value of the constant annual cash flows is exactly equal to the project's net present value. When used to compare projects with unequal lives, the one with the higher EAA should be selected. The EAA approach is relatively easier to use rather than the other method used to compare projects with unequal lives, the replacement chain or common life approach. The present value of the constant annual cash flows is exactly equal to the project's net present value. Now, let's understand an important aspect of inflation and its relationship with capital budgeting. The capital budgeting results would be unrealistic if the impact of inflation is not incorporated in the analysis. The cash flows would not reflect the real purchasing power. In order to overcome this problem, the company should rely on real cash flows, which means cash flows discounted to reflect effect of inflation on nominal cash flows. The company should also rely on real cost of capital, which means cost of capital adjusted for inflationary effect. At the end, let's summarize the whole thing. NPV, IRR and Profitability Index are the discounted techniques which are superior to the non-discounted techniques of capital budgeting. In most cases, firms do not have access to unlimited amounts of funds, or financial managers do not have access to additional funds, which might mean that some acceptable capital budgeting projects are not chosen. If the amount of funds that is invested in capital budgeting projects is constrained, then capital rationing exists. In such situations, the firm should invest in the combination of projects that provides the highest combined NPV, that is, that increases the firm's value by the most. When evaluating capital projects, companies can evaluate capital projects in nominal or real terms. Real cash flows are based on purchasing power at the time the decision to investment is made. Commonly, capital projects are analyzed in nominal terms, so the discount rate applied is inclusive of expected inflation. However, actual inflation may change direction from expectations, and inflation may impact the different project variables in different ways. Thank you.